So now I'm going to talk about factory methods to measure the moisture content of pressed cane in Louisiana factories. So you know the moisture content is a really important analysis because that's involved in the current Louisiana cane payment system. So based on this analysis, pulp, bricks, and sediment, they estimate how much the factories are going to pay to the growers. In this study, we study only moisture in pressed cane, which is the sample that we took in the core sampler, then we shredded the cane, and then we pressed the sample in the hydraulic press. That's what we call pressed cane in this study. How do they measure moisture in the factories? They weigh around 50 grams of pressed cane, they dry it at certain temperature and time because that depends on the factory, and then they reweigh the sample. And this drying process is made in a big oven, so the factories have many ovens in their core labs in order to do this analysis. Last grinding season, we did a benchmarking of the moisture analysis in all the factories, and we noticed that drying time and the drying temperature changes among the factories. You can notice here that some factories dry the sample at 150, another factory dry the sample at a higher temperature, around 175 Celsius degrees. And with the time also changed. So factory dries the sample only for 70 minutes, but there are another factory that dries the sample at 180. So you can notice here that the times and the temperature changes among the factories, and we want to know if this is affecting the moisture analysis, the moisture accuracy and precision. And there is another parameter that also changed among the factories is the kind of ovens you are using in your labs. So we have many brands. There is actually one oven that use forced convection. So we also want to know if this is affecting the moisture analysis results. And we start this study because I'm working with the NIR. We are trying to update the Louisiana cane payment system, and I was analyzing moisture with the NIR, with the near infrared spectrometer, sorry. And we noticed that the correlation with the NIR results and the moisture analysis in the factory where we installed the NIR, the correlation of these models was really low. You can see here we don't have a really good correlation. So the only reason we notice it could be affecting this result is the moisture analysis by itself. Or we also know we have to add more analysis to these models. So that's why we started with this study to check if the moisture methodology is good enough and the accuracy is good enough. Unfortunately, we know the oven methods are very tedious and it takes a lot of time. It takes up to 180 minutes. And we need large ovens, and that takes a lot of space in the labs. So we need a really faster method because we are going to be able to analyze more samples, and we are going to save space and save labor. So there are some alternatives, options in the industry, and we know there are some moisture analyzer or moisture balance available. Some industries are already using this. Actually, some sugar factories use the moisture balance to analyze moisture in sugar. So we just want to test if those equipments also work for pressed cane. The important about these equipments is that those equipments are smaller, they are faster. We can have a result in 5 seconds up to 5 minutes, and some of them are also cheaper. Some moisture analyzer have been developed especially for industry purpose, so they are rugged. As I say, just the sugar industry had been using some of those balance for sugar moisture in sugar. So we just wanted to test this kind of new equipment. The methodology that we used for this study was, first we obtained the pressed cane samples from some core labs. We split the sample in two because we want to test the moisture accuracy under two different levels of moisture. So we split the sample in two. We had one sample for low moisture. We add water to the rest of the sample, so we were going to have a higher level of moisture. And then with dry samples, we dry the samples 8 times in duplicate. That means we analyze each sample 16 times in total. That's what the ICUNSA recommend for precision and accuracy test. And finally, we calculate the moisture content. So here we compare two techniques to analyze moisture. We use the oven method, which is the method you are using in your factories. And to do that, we weigh 50 grams. That was the amount that we used for this test. And we test the moisture precision and accuracy in 4 factories using the methodologies they are using in their factories. Those are the conditions we were testing. And we also test the CSC digital moisture balance, which is a balance that we bought in order to compare the precision of this equipment with the oven methodology. First, before talking about accuracy and precision, I just want to explain you a little bit about what's precision and what's accuracy. So in this case, we have here high accuracy and high precision. Why? Because accuracy means the results of the analysis is close to the real result, which means if we are analyzing moisture, we have to be close to the real content of moisture. And precision is the variation of those results. So in this case, we are close to the center, which is the real result of moisture, and the variation is really small. You can see that all the samples are really close. In this example, we have high accuracy because all the samples are around the center, are around the real value, but we have low precision because you can see there are some variations. Here we have low accuracy because all of the samples are close. The variation of the analysis is really low, but, we had a high precision, but we have low accuracy. Why? Because the samples are really far from the center, which is the real moisture result. And in this last case, it's the worst case. We have low accuracy, low precision, because they are far from the center, and the variation of the samples is really high. So that's what we don't really want, and this is what we want with any method that we are using in our labs. In order to do this test, for the precision test, we took one sample at each factory, and then we analyzed that factory in each that sample in each factory. That means we had different sample in each time that we were analyzing the samples in the factories. For the accuracy test, we used one sample, and it was exactly the same sample in all the factories. We split the sample into 4, and we used the same sample for all the factories because we were comparing the real moisture content. Those are the results for the oven method. Here in the first table, you can see the precision results, and we can measure the precision based on the variation coefficient, which is the CV. This is the CV, and if the CV is really high, that means the precision of the methodology is really low. So we want a CV below 5%. That's what the ICUNSA recommends. And you can see here that all the results from all the factories, all the methodologies, gave us a CV below 5%. That means that although the factories are using different temperatures and different times, the precision of all the methodologies are really good, the CV is below 5%. And accuracy, we can notice that we might have a problem with accuracy because you can see here 2 factories are having a moisture content around 41.8%, but the other 2 factories are having a moisture different. So one factory was having 42 and the other one 43. So that means that we need to adjust a little bit the temperature and the time because the result should be similar in all the samples. For the balance, the CSC balance that we test, the CV was similar here. It was a really low CV. That means that the precision of this balance is really close to the precision of the oven. But if you compare this with the previous results from the oven method, you can see, I'm going back to show you this. You can see here that with the oven method could have CVs up to 3.3%. But with the balance, we never had that CV. We had always lower values, so this kind of balance could give us a better precision because the CV is lower. And about accuracy, I really can't say much about accuracy, because if we want to measure real accuracy, we need a standard methodology for moisture, and we still don't have that methodology. We know there are some methodologies that measure the real content of moisture, and we are going to work on that in the next couple of months. So, but if you notice here, the results of moisture from the balance was 41.7%, which was pretty close to the results we were having with the oven method. So it looks like this balance is a good equipment for this kind of analysis, and the precision is even is a little lower, a little better than the oven method. This is just to compare the results. Here you can see 41.7% of moisture with the balance, and with the oven methods we had a similar result. But remember that the accuracy of the ovens, we have to work in that, because we are having different results in each factory. As conclusion, I just can say that the drying time and temperature of the methods, as well as the moisture of the sample, strongly affect the results. All the methods gave us a really good CV. The precision of all the methods are really good, because are below 5%. But as I say, the precision of the balance was generally better than the precision of the oven method. The results of the balance, talking about average and standard deviation, were generally similar to the factory oven methods. The accuracy of both methods has to be estimated after we found a standard method for moisture. And this is just an ongoing study. We are going to work on this, because we are going to test another equipment, which is going to be a moisture analyzer, and we are going to compare that one with the current Louisiana moisture method. I just want to thank to American Sugarcane League for full funding, and to all the factory staff for all their help.